Hello friends, this is all about combining resistance and various calculations involved therein. I've got two circuits here. One circuit is a series circuit and the other circuit's a parallel circuit, which I've just realized I've forgotten to write parallel on, but you know, I'm not a professional anymore. I'm working from home, you've got to forgive me. There are two formulas you need to know here. One for calculating the total resistance of a circuit in series and one for parallel. We'll get onto that in a second. Let's worry about series. Now there is another thing I need you to understand, the meaning behind these formulas. So here, without any further ado, is the actual formula for the total resistance of a series circuit. And this is it. And it's to be expected. The more you think about it, the more it makes sense. Right? This basically just says that the total resistance of a circuit equals the resistance of the first resistor plus the resistance of the second resistor plus, as many as you have. In this particular case, we have 3, so we just add those 3 together. 2 plus 3 plus 1 is 6. The total resistance of that circuit is 6 ohms. But it's worth understanding why. Right? Now, as before, electrons come out of the battery that way, and at the moment they've got 12 volts of, of energy per coulomb, right? 12 volts of voltage, 12 volts, 12 volts, 12 volts. And they're going to be slowed down here. They're going to lose some energy there, right? So they have less than 12 volts. We'll worry about calculating how much less in a minute, but they've got less. They've still got some of it left, right? But having been slowed down, they're then going to go through there as well and be slowed down again, and to have more energy taken off. And having had energy taken away there and taken away there, they still have to go through that one and have the energy taken away there. So the three difficulties, the three places where energy is taken from them, are experienced one after the other after the other. Every electron that comes out of that battery is going to have to go through all three of those. And it's going to be slowed down by that much and by that much and by that much. So it makes sense that the three resistances would be added together because they're sort of working together to sap the energy of the electrons, right? So this makes sense. Right out. Analyzing this circuit using calculations. Typically, the first thing you'll have to find out, no matter what somebody asks you about this, the first thing you'll almost certainly have to find out is what the current in the whole circuit is. A typical question is, for example, what would be the voltage across that resistor or a resistor? To do this, you need to use V equals IR, of course, and you need to use the V there, the I there, and the R there. We did this in the other video. They all have to be for the same area of the circuit. Now, the good thing about a series circuit is that the current is the same all the way around, right? Because current is just counting the traffic, right? If there was somebody standing there literally counting the electrons as they went past, if 10 electrons went past there, then 10 electrons would eventually go past there and past there and there and there and there, right? There's nowhere else for them to go. So if the current, whatever the current is there, it's going to be the same everywhere around, right? So the current for this part of the circuit is going to be the same as the current for the whole circuit. There's only one value for current anywhere in this circuit. So this is what you have to do. If you get a question that says, and this is a very typical, worth a few marks in a VCE test question, right? Find the potential difference. Sometimes it's called the voltage drop across the 1 ohm resistor. That's a very typical question. All right, here's how you do it. The last thing you're going to do is use V equals IR. So this is sort of your plan here. This is what you don't necessarily have to show the person who's marking it, but this is what goes through your head. You know that the very last thing you're going to do is use V equals IR and find I, right? I equals V divided by R. But it's the V there, sorry, you're not going to find I, you're finding V. Sorry, but it's the I there and the R there. You've got the R, you haven't got the I. So the second last thing you're going to do is find I. Right? And you're going to use I equals V divided by R, but this is for the whole circuit because you know that the current that you're finding is for the whole circuit and the voltage you're going to use is that 12 volts, and that's for the whole circuit. All right. So that's step one, that's step two. If you can't figure out what to do first, figure out what to do last. And you can often work your way backwards, and there's your sequence. Once you get to something that you can do now, you actually have your plan written down. Right? Working backwards is a very good problem-solving device. All right, so let's do it. Firstly, find the current in the circuit. And another great habit to get into is telling yourself what the hell you're doing. Right? In a question that's got 2 or 3 sections, you often don't remember what you've done. Right? Some of these things get enormous. Some of these things get like a page long, and you can't remember what section of it you've just finalized when you get an answer on your calculator. And you really have to start all over again mentally and think it through. All right, so let's do this. The total current in the circuit is the total voltage divided by the total resistance. The total voltage is 12 volts. The total resistance is found using this, right? 1 plus 2 plus 3, 2 plus 3 plus 1 is 6, so 6 ohms. 12 divided by 6 is 2 amps, easy. All right, done. Down here. And again, tell yourself and tell the person who's marking this thing, right? You're finding the voltage across the 1 ohm resistor. This is the bit where you're answering the question. It's very handy to do that. The people who mark your results, by the way, the people who mark your exams love this sort of stuff as well. It's easier to find the marks that they should be giving you. Okay, V equals IR as per your plan. Equals, now you got the I, 2 amps. That resistance, right? That was V equals IR for the whole thing. This one is just for across the 1 ohm resistance, so we're just focusing on this 2 volts. So going through that resistor, every coulomb of electrons loses 2 joules, right? Voltage is joules per electron, right? So they must only have 2 volts left there because there's nothing else to take energy off. And you remember that if this has got 12 volts, all of the voltage has to get used, right? So it has to end up with 0 there. So now you know they've got 0 there, they must have 2 there. All right. That's about as hard as analysing a series circuit gets. They're pretty simple beasts. Here's a parallel one. Just let me addend this. Parallel. That'll do. Or did I spell parallel wrong? Right in. Okay. Parallel circuits. New resistance formula first. That's not it. And this one will take some explaining. So here is the parallel resistance formula. To find the total resistance of this circuit, to find all the resistance that the electrons coming out of here are going to be fighting against to get round there. This is the formula. 1 over the total resistance equals 1 over the first one, plus 1 over the second one, plus etc., for as many resistors as you've got, just like this one was. Right. Now this is a little weird. Every time you do this, the total resistance actually comes out to be less than the smallest resistance that you've got. So I can tell you straight away, without even doing this at all, the total resistance of this circuit is less than 1 ohm. Right? So how does that happen? Let me sort of explain it to you like this. Pardon me. Let's just assume for a second that we didn't have that and we didn't have that. Right? So these guys are out of the picture for a second. Right? In fact, they're out of the picture. No one's commenting about my choice of phone, by the way. Okay. So if this was just a series circuit with one ohm resistor there, obviously the resistance of the whole circuit is 1 ohm, right? Electrons come out here, they still have 12 volts, they lose it all there, right? They've got to go through, they lose it all there, 0 volts, 1 ohm resistance. Now let's add this one in. This makes the job easier. This makes the job of electrons going around the circuit easier, because as well as being able to go through there, some of them can take the extra lane. It is literally turning a 1-lane road into a 2-lane road, even though there's a speed bump there as well. It's a bit like being in Coles and having one checkout open and somebody opens another checkout. The other checkout's going to be just as slow as the first one, but at least there's two of them. It still speeds things up overall. It's better to have two slow lanes than one slow lane. Right? So the resistance of this will be less than the resistance of just that. Right? There's more metal to go through, literally. So that is easier, and that is easier still. So it turns out that when you calculate this, every single time the total resistance turns out to be less than the resistance of the smallest value you've got on the whole thing. So let's run you through this. This is a bit of a calculator nightmare as well, by the way. So we're going to go to this. So if you had a question here that says, A, find the total resistance of the circuit, right? Total R. Okay, let's do it. 1 on RT equals 1 on the first one, 1 on the second one, 1 on the third one. That's it. So we have to solve that for RT. Step 1, add all that together. A half plus a third plus 1 is 1 5/6. Trust me. So that is 1 5/6, which is 11/6. It's handy to be good at fractions with this, because this is literally a fraction-filled formula. You can use it on a calculator and just get decimals and so forth. That's fine. It doesn't matter. You'll still get it right. But I just find that this is one of those rare cases where fractions are actually fairly useful, and they are a faster way to do things. Okay, that's not the answer. Rookie error is to get that, add all these things up and go, yep, that's it. That's not it. Right? Firstly, that's bigger than 1, and you know it has to be smaller than 1. Right? But secondly, this said 1 over R total. A classic rookie error in the fog of war during an exam when you're stressed out, you're looking at the time, is you do all of this and you forget to flip the answer because that says flip it. Right? The answer, you have to say, therefore, the total resistance equals 1 over that, which is 6/11 of an ohm, or I think that's 0.656565 or something. All right. Again, you can just go 6 divided by 11 equals on a calculator, and I'll get it for you. But that's fine. Leave it in fraction form. So the total resistance of this circuit is 6/11 of 1 ohm. Right? And if you then had to find the total current of this circuit, in other words, the current that comes out of the battery, you'd have to use that resistance because that's the total resistance of the circuit. So let's do that. Part B. Find total current. You end up getting a lot of different figures for a lot of different places in some of these questions. You've got to keep everything in its place. We're talking about the total current, so we're going to use the total voltage and the total resistance. V equals IR, therefore I equals V divided by R. Sorry guys. Which is 12 divided by 6/11. Grab a calculator, figure it out. Don't try to do that in your head. Having said that, I think I've just done it in my head, but I'm not going to trust myself. 12, now divided by 6/11 is the same as you've divided by fractions before 1,000 times, right? You flip the fraction, you multiply it by. So I'm going to multiply it by 11 and then divide it by 6. Hey, I was right. 22 amps. That's a lot of electricity. 22 amps. It's like an oven. So 22 amps of electricity is roaring out of this thing with 12 volts, and it splits up because splitting up is the easiest way to get around the other side. Beautiful. Part C. This is where they normally ask you about one of these branches. So let's pick on this one, right? The 3D. Find the current through the 3 ohm resistor. By the way, if they ask you to find the voltage across that, that's a very easy answer because we did this in another video, right? 12 volts, all of the electrons that go this way are only going to go through that 3 ohm resistor. So the only place they can lose their volts is there. So it's 12 volts from one side of there to the other. Right? Same with this one, same with this one. That's why light globes in parallel are bright and light globes in series are dim. We've done that before. Anyway, find the current through the 3 ohm resistor. All right, again, it's V equals IR, therefore I equals V on R. But again, you've got to get the right numbers. It's just for this now, not for the whole thing. So the voltage across there is still 12. So the V that you're going to use is still 12. The resistance is not this 6 on 11th this time, it's the 3. Right? Find the I. Right? When in doubt, stop, take another 10 or 15 seconds and do this list. Actually write it down. Right? Make sure you've got it right. That's where all the physics is. Right? From here, a 10-year-old can do this question. Right? All of the brains is getting this bit right here. Right? Pick the right numbers. Any schlock can put the numbers in a formula. That's no skill. So, like I'm showing you now, any schlock can do this. All right, 12 divided by 3 is 4. Even I can do that. 4 amps. Okay, that, my friends, is analyzing resistance 101.